Well, here's another series in our series of fun problems. So when you take a look at this, the 2/3 should pop out at you. If it's 2/3, then that's a geometric series, and with it being 2/3 less than 1, then it's going to converge. But for a geometric, it's supposed to look like a number in front, and then r, the ratio, is raised to the power. And then it can start at 0 or 1, or this one starts at 1. So we need to know what's the r. I'm pretty sure that's the 2/3. What's the number in front? Well, notice in here, this has 2 to the n, and this has 3 to the n. So we'll be able to say this is going to be 2/3 to the n, but this 2 has an extra 2 in its exponent. So you could rewrite it as 2 to the n times 2 to the 2. Then the 2 to the 2, or the 4, you can put in front, and then this is 2/3 being raised to the n. And then that means it's a geometric series with r equals 2/3, which is less than 1, so it converges. Now for some additional fun, that means this thing adds up to a finite number, so what is that finite number? So one way to do it is you start adding up the terms, so it's going to be 4 and then substitute in 1, so that's 2/3, plus 4, and then it's going to be 4/9, and then it's going to be 4, and then when you raise it to the 3, it's going to be 8/27, etc. And then if you really liked calculating these things by hand, you could factor out the 4 and say, well, I just need to figure out what this is. You could even use what's called the partial sums, where you go, all right, well, to add up all infinity of them at once is sure a lot of work. I could add up these guys and then find out what it's going to. So I could take 2/3 plus 4/9 plus 8/27 and find out what that's going to. So the partial sums, so I added up the first 3, so that's called S3 is equal to a 4, because I factored out that 4, remember. And then when I added up the fractions, I got 38/27. And then S4 would mean add in the next one, which is going to be 2 to the 4th divided by 3 to the 4th. So that's going to be 4 times a 130/81. So then the idea is, what number is this becoming when you keep adding up more and more of them? So next would be add in 2 to the 5th divided by 3 to the 5th. And then S5 would equal 4 times 422/243. So you could keep doing this until you find the pattern. Well, notice the denominator is that 3 to the 5. So that's what the denominator is. Then you have to figure out a pattern for the numerator. Alright, so that's one way to do it. Another way to do it is on the calculator, use sum sequence. and then the function is 4 with 2/3 raised to different powers as x goes from 1 to... So then you just try different numbers. Let's see, how about if you go 1 to 20? So then you would have S20 is equal to 7.998. How about if you go to add up the first 50 terms? Come on, calculator, you can do it. And S50, so by adding in an additional 30 terms, it's now pretty much stuck at 8. Let's try one more. If you go to 75, is it going to go past 8.0? It seems to be 8.0. So I'm saying that's what the sum is.